and the oxygen will not let him die. Okay? So the same thing we follow here. We take a polymer and we bring the polymer with the interface of a good solvent and bad solvent. If you have only good solvent, the polymer will dissolve the solvent. If you have only bad solvent, it will give you very strong interface tension. But if you have the mixture of good solvent and bad solvent and appropriate composition of this mixture of the good solvent and bad solvent, it will probably give you a negligible or zero interface tension. But the problem is that, let's take example of water. So you have water here, or let's take example of aqueous. Let's say you have a glycerin here. Glycerin is aqueous. Okay, glycerin gets dissolved in water. So, for example, the water can be a good solvent, and glycerin does not dissolve in oil. So the oil can be a bad solvent. But the problem is that water and oil, they themselves do not mix with each other. So how do you get this clustering mixture? So people have studied this phase diagram of liquids, and our life is not that bad because we don't have to make the zero substitution for water. We are trying to make it for polymers. So what we do, we take a polymer bed, we take a partially good solvent, a partially bad solvent, and then a very unique co-solvent which basically dissolves the good solvent and bad solvent together. So the right hand side medium still is a single phase. There is no phase separation, that the good solvent, bad solvent are like islands. This is still a homogeneous solution, and once you bring them together with the appropriate composition, so this is the tuning of the interfacial tension. Normally the spherical shape of the drop is because of the high interfacial tension. Right now this polymer is a PDMS, very common polydimensional siloxane, or in the simple words, silicone oil. And what we have taken, water is a bad solvent of silicone oil, IPA is a co-solvent, and hexane is a good solvent. Now the job of the IPA is to bring the water and hexane together and still give a uniform composition. And after tuning the composition of water, IPA and hexane, you see that the spherical drop shape does not follow a sphere at all. The water becomes a long cylinder, which is completely unstable configuration for any liquid in air. Because of the high interfacial tension, it will always form a curvature and will tend to make a drop at the end of the liquid.
Why do we need zero interfacial tension?
That's the answer. Okay. So, for example, in lithography, those who work on the devices, okay, let's say you want to make a lithography. In the lithography, you want to make some devices. Okay, you want to make a rectangular channels. Now, if you go to the very sharp corners of these rectangular channels, because when you are doing lithography, you are using some photoresist, which are still in the liquid state. So, when you are doing the lithography and you zoom into the very high magnification of these 90-degree corners, you will see the rounding. This is because of the finite